Welcome back for our last note video for chapter 6. So today we're going to continue developing this idea of inverses. So yesterday I threw a lot of information at you. So again, I would just like to recap what exactly my expectation is that you know, okay? What am I really looking for? What I'm looking for is, can you find an inverse, and can you tell me if the inverse is in fact a function or not, okay? Those are the two big ideas I need you walking away with. So remember, to find an inverse, remember we're talking about that original f of x is a y, and we want to swap those, okay? So we want to swap that y, okay? And now we want to resolve for y. So I'm going to subtract that 9 and divide by 2. So there is my inverse. And again, if you're thinking about, is the inverse a function or not? Well, that is actually just a line, right? And if you're dealing with something that's a straight line, the answer is yes. That is going to still be an inverse. And again, equation-wise, we can tell that the inverse is a function because it didn't get that awkward plus or minus in there. All right, what about this one? Well, this next one, we're dealing with swapping to call that a y, and now swapping the x's with the y's, okay? So we swap that, and now our goal is to try to resolve for y. So I have to square both sides and then add the 2 over. So here, once again, what you should be picturing, if you remember from the last notes, you should be picturing a piece of a parabola, okay? And of course, any piece of a parabola is going to be a function. So yes, this inverse is also a function. And again, another good way, easy way to tell that is because you did not end up with a plus or minus in your equation. So continuing on to our next one. So again, going to immediately call that a y. And then to find the inverse, remember we just swap them. So subtract 1, divide by 5. Oh, I'm sorry, I forgot to actually swap them. I'm sorry. I should have called it this and then started doing all that work, right? Subtract 1, divide by 5, and now cube root. And if we're picturing a cube root function, that's going to be something that looks like that. Again, a cube root function is going to pass the vertical line test. Okay, so it does pass the vertical line test, or again, the other thing that you'll notice is it did not get the plus or minus, so it's not getting all messed up. Our last example for the day, or not for the day, but for this brief recap, is call that y, because then we can swap them. Remember, the process of swapping them is what is creating your inverse. And now I have to resolve for y. Now this is where when I go to square root this thing to break the y plus 3 free, because I take the process of square rooting, remember that's where the plus or minus comes from. Subtract the 3 over. So this is my inverse. And if you think graphically, having a square root is going to be something that looks like that. but having the negative of it is going to create that branch down there. So that plus or minus, that is what makes this thing fail the vertical line test. So no, that is not a function. It fails our test. Okay? So again, that's the big idea from yesterday. Now, down here, this is a little recap, little explanation. For a relation to be a function, remember it means x can only map to a single y value. So if you think of that also having to happen in the reverse, basically that means x can only go to a single y. In order for the inverse to be a function, it means y could have only gone to a single x. Okay? And that we actually give a special name. We call that a one-to-one function. Okay? Means x can only go to a single y and y can only go to a single x. That's what allows the inverse to be a function, okay? Just some fun little vocab for you if you're interested in kind of a new mathematical idea. That is what we're talking about, one-to-one. So now I do want to make a relationship with you between the inverses we've been doing and composition of functions, okay? So the first thing I'm going to do is I'm going to find this. That is just a fancy notation for the inverse, okay? So I'm going to find the inverse of this function, all right? So I'm going to always picture that as y. So I'm going to swap them and resolve for y. All right, so what we have f of x was 2x minus 7, and now its inverse is x plus 7 over 2. All right? So that's what we've got right now. Again, you should know finding the inverse is always just flopping x and y and then going from there. And what I'm interested in now is let's talk about composing these together. Okay? So remember composition of functions. Remember this is saying f of f inverse of x. Okay? And we just found, remember, that the inverse of x is x plus 7 over 2. So now in my original f function, that's what I'm going to replace everything with. Okay, so in the original f function, I'm going to replace x with that now. Okay, and now let's notice what happens. Well, remember, these twos can cancel. So I just have x plus 7 minus 7. And I just get an x. Let's talk about doing that process, that composition process in the reverse. So now I'm going to start with the inverse, and I'm going to take the inverse of the function of x. And remember, the original function was 2x minus 7. So what I'm going to do is in my new function, I'm going to put that in the place of x, okay? So I'm writing the inverse, but I'm substituting in that 2x minus 7. Well, those cancel, and I just get x again. So that's interesting. So when I compose it both ways, notice what I got, okay? Now, this might be just a coincidence, so let's do another example, okay? And see if this works again, all right? So I'm going to find the inverse of this function. So to find the inverse, I'm going to swap the x and y. And now I'm going to solve for y. So I'm going to multiply the x over and subtract 3. So my f of x is x plus 3 over 4. That was my original function. My inverse is going to be 4x minus 3. And let's do this process again, okay? So I'm going to take the function of the inverse of x. All right, that's what that's telling me to do. Well, the inverse is 4x minus 3. So in the original function, I'm going to put that 4x minus 3 in the place of that x, okay? Negative 3 plus 3, so I have 4x over 4. Those cancel, and I just get my x back. All right, let's do it in the reverse order. The inverse of the function of x. So this time, the original function was x plus 3 over 4. Now I can go and I can compose that in. So now, in my inverse function, I'm going to substitute in the x plus 3 over 4. Substitute my original function into my inverse function. These 4's cancel. Or 3 minus 3 cancels. So here, that very same thing happened again, okay? So I'm left with just x's. So this is actually a very interesting property that I want you guys to know, okay? So if you flip over, this is where we can kind of recap that. So if f and f to the negative 1, if those are inverses of each other, what's true? When I compose them into each other, they should just give me x, okay? So both ways, you should just have an x left when you compose them together, okay? And again, that's kind of a neat trick, okay? It's a way to verify if something really is an inverse, right? Just compose it, and it should give you just an x back. Now, one last thing, okay? So when we're dealing with the real world functions, you can't just flop the variables and resolve, okay? So what you really have to do is just get the independent variable by itself, and that'll create the inverse function. So what I'm talking about here is we have this function d equals 4.9 t squared. And it's saying that that represents the distance in meters an object falls after t seconds. And it wants us to find the inverse of that function. So instead of finding or of flopping d and t, basically in this instance, what we're going to do is we're just going to walk through the process of getting t by itself. Okay, so this is what you do for real world situations. So for example, I would divide by that, and then I would square root. Right now, technically, we should have a plus or minus out there. However, because it's a real world situation, it wouldn't make sense to be able to talk about negative time, right? So here, for this real world circumstance, I'm going to neglect that plus or minus simply because you're not going to have a negative time in the real world, okay? And now we can use this new equation to solve. How long in seconds does it take for the cliff diver shown to reach the water below? So it shows that the cliff diver is 24 meters high. So we can just plug in that 24 into this equation and we can calculate that. So square root of 24 divided by 4.9. It's going to take this skydiver about 2.21 seconds. All right, and again, that's just real world situations. You're not swapping the variables, you're just getting the variable alone. All right, so again, a lot of good stuff today as we talk about inverses and relating them to compositions of functions. So now that you're done, I'd like you to write your summary for me and then come back ready to do your practice work in class.